Welcome to Big Data Now. Today, we're diving into PyTorch, one of the most popular frameworks for machine learning and big data applications. Why is PyTorch a must-know tool for big data? As the amount of data we generate skyrockets, think petabytes every single day, organizations rely on machine learning to uncover patterns, make predictions, and automate decisions. PyTorch simplifies this process with its flexible design, powerful features, and GPU acceleration, making it the tool of choice for data scientists, researchers, and developers. In this video, we'll not only explain why PyTorch is a game-changer, but we'll also build hands-on examples, including a predictive analytics model and an image classifier. Stick around, and by the end, you'll have the knowledge to start using PyTorch for your own projects. Let's jump in. So, why is PyTorch so important in the world of big data? Let's break it down. First, scalability. PyTorch supports distributed training, allowing you to train machine learning models across multiple GPUs or even servers. This is critical when working with large datasets like video feeds or customer transaction logs. Second, its dynamic computation graph. Unlike other frameworks, PyTorch allows you to build and modify models on the fly, which is especially useful for debugging or experimenting with custom architectures. Third, PyTorch is at the heart of a rich ecosystem. Libraries like TorchVision, TorchText, and PyTorch Lightning extend its capabilities for specific big data tasks, whether you're working with images, text, or time series data. Finally, the community. With wide adoption in both academia and industry, PyTorch ensures you're using tools that align with the latest research and practical applications. Now that we understand why PyTorch is so valuable, let's start with the basics. PyTorch revolves around one fundamental building block, the tensor. If you've worked with NumPy, you can think of tensors as multidimensional arrays, but with one key advantage: they can run on GPUs for massive speedups. Let's see this in action. We'll create a simple tensor, perform some basic operations, and see how easy it is to transfer tensors to GPUs. You'll also learn how to convert tensors to and from NumPy arrays, which is incredibly useful for integrating PyTorch with existing data workflows. Tensors are the foundation of everything in PyTorch. Whether you're building models or performing data pre-processing, you'll be using tensors extensively. With that in mind, let's move on to our first real-world example. Now, let's apply PyTorch to a real-world task, predictive analytics. Imagine we have a small dataset of house sizes and prices, and we want to build a model to predict prices based on size. First, we'll define a dataset and use PyTorch's DataLoader to handle batching and shuffling. This is particularly useful when working with big data. Next, we'll build a simple linear regression model using PyTorch's NN module. The model will map input features like house size to output predictions, such as price. Once the model is defined, we'll train it using gradient descent. PyTorch handles all the heavy lifting for us, from calculating the loss to updating the model's weights. After a few epochs, our model will be ready to make predictions. This example shows how intuitive PyTorch is for building and training machine learning models. Even with a small dataset, you can see how this workflow scales to larger, more complex projects. Next, let's explore how PyTorch handles image data. Using the TorchVision library, we'll build a simple image classifier. TorchVision provides pre-built datasets, transforms, and models, making it easy to work with image data. We'll start by loading a sample dataset, applying transformations like normalization, and preparing the data for training. TorchVision's pre-trained models, such as ResNet, can be used to classify images out of the box. This makes PyTorch an excellent choice for big data tasks involving images, such as object detection, medical imaging, and facial recognition. By leveraging TorchVision, you can save time and focus on fine-tuning models for your specific use case. And that's PyTorch in action. From predictive analytics to image classification, PyTorch makes it easy to build powerful models for big data. If you enjoyed this video, please like, subscribe, and share. Let us know in the comments what PyTorch topic you'd like us to explore next. Thanks for watching, and see you in the next video.